So hi everybody, welcome back to YouTube, and today we are going to solve this 2698 Leetcode problem, find the punishment number of an integer. So let's get started. So today the problem statement says that given a positive integer n, return the punishment number of n. So the punishment number of n is defined as the sum of squares of all integers I such that I is between 1 and n. So we have given an n integer. We have to just return the punishment number of n. The punishment number of n is defined as the sum of the squares, that it lies between this 1 to n range, uh, that is inclusive. And then there's one more point, that the decimal representation of I into I can be partitioned. I into I is basically the square, can be partitioned into contiguous substrings, okay, such that the sum of the integer value of these substrings equals I. Okay, got it. Let's see an example to get more clarity. So we have n is equals to 10 and the output is 182. How? So there are exactly three integers in the range 1 to 10 that satisfy the conditions. So 1, since the square of 1 is equals to 1. Then 9, since 9 square is 81, and 81 can be partitioned into 8 and 1, which is a sum equal to 9, which is the number itself. Okay, and with 10 is also it's 100. Then we can also partition it to 10 and 0, and sum equal to 10, that is the number. And the punishment number of 10 is the sum 1 plus 81 plus 100, which is 182. Okay, so just by reading this, um, I get a hang of, like, we have a limit, we have a range, and there are certain numbers only which can be uh, you know which can be partitioned, and then their sum is also equal to themselves. So there are only certain numbers within a range. So for example, in 1 to 10 there are only three numbers. So it doesn't matter that if so suppose if you have a range 1 to 12, then uh, the numbers between the range 1 to 10 will also lie in that range, that they are going to be the same. There will be no addition based on the n. And then after 10 to 12 there can be some numbers as well again. So we can like find these numbers first, and then we can like also store them somewhere, and then we can just simply sum it uh, based on the n provided. We can do that as well. This is just the thought which I got just after reading this first example. So again the next one, 37. So there are exactly four integers. Again, as I said, 1 to 10 there are three integers, so there will be always three integers within that range. And then a new integer adds up only after like 36. So 36 is 1296, the square of it, and it is partitioned. Okay, so there can be multiple partitions as well. It's not like we have to partition like only with two substrings. We can be like multiple substrings. Like in that case, you can see at 1296 is partitioned into three substrings, and these three substrings when added together makes the sum 36, which is the same number themselves. So that's why it's a valid number to be considered for the sum for the punishment number. Let's look at the constraints as well. So constraints are n is under 1000. So this just gives me a signal that the constraints are small. So a solution within the time complexity of O of n square can also pass easily, and we can think of it later. So the constraints are small, so I think a brute force solution will also work. Let's start with the brute force solution first. So the first solution which is coming right off my head is, we have this n. So we can go through all the integers within this range starting from 1, 2n, and we will check if this number in the range, if it satisfies these two conditions, like the partition one and if partition one, and then if it is equal to themselves, then we can add the square of it into the punishment number. And this is we can do for all the numbers in that range, one by one. So definitely this can be a valid solution. So um thinking of how we can like test it out for each of the numbers if that's a valid number. So let's just open a Google Doc. I should have opened it earlier. It just reduces time. Okay, so let's take the example of this 36th, or we can also take 9 1. So if the square, let's write the squares first. Right, 1 square is 1, 2 square is 4, 9, 16, 25, 36, and so on. We can, I'm just trying to understand if there is a pattern in those numbers. Somehow we can like figure it out. So you can see here, one is one, we cannot like partition it. So if the string length is 1, then simply check if it is equal to itself or not, because we cannot do anything if it's uh, lesser, if it is equal to 1. So this is one pattern which I found. So let's find a pattern for the 2-digit number as well. Let's take the example which is in the question itself. Let's do for 9 square. 9 square is 81. How can I know that 81 is valid? So what we can do is, I know that 81 is a square of 9. uh, I can like partition it this way. I can like tell it, okay, separate 8, and the remaining string will be sent, we'll check this later on. So if I need to check the remaining string, I if it is valid, then it's got to be sure that the number which is this one, if it is square of 9, if I remove this part, then the rest of the part should be equal to that subtraction. So let's say 81, I have partitioned it, so it should be like, now the 81 is square of 9 minus the subtraction of the number which I removed from it, 8, and it should be equal to the rest of the number which is 1, rest of the number. And if it, yes it is, so it's a valid. So here we can do that, and it can also work for all the even 3-digit numbers and 4-digit numbers. So we can see that, let's take a bigger number which is 36. So for 36 square is 100 and 1296. So 1296. And now let's try to partition this number. Let's say we have partitioned it from here. So now in order, if it's valid, then what should happen? Then this number can be partitioned to the subtraction of the square minus the number we have separated it. So we separated 1, so it should be converted, or it can be partitioned. So 296, the rest of the string can be partitioned 35. If it is, then it's a valid number. Let's try to do that as well. So the next number is 296, and we are trying to partition it for 35. Can we? Let's try. So let's this time we are making a partition over here, 29 and 6. So again, if 35, which is the number, subtraction or minus the number we have separated, which is 29, it becomes equal to 6. Now if the rest of the string can be partitioned into the remainder, then it is valid, and which in turn valid. 6 can be partitioned to 6, and which it returns true, and it's a valid number. So I can like clearly see this is as a recursive loop of checking over and over again for all the numbers. So again, another hint which I another pattern which I got is I got a hint for recursive loop. So it's kind of we need recursion. So what we will do is we will just partition it for each and every possible way, and we will remove the subtraction, we will check the subtraction, and we will try to uh, check the rest of the string if it is possible to partition it into this, and if it is, then we will add the square of it. hmm so this is a brute force kind of solution. um we need to like do it for the optimal way if I am able to find it, but I think there's no optimal way I can like think of it right now. The constraints are already very small, so brute force recursive way can also work. And see, we need to check each number once, so it's going to be costlier than O of n for sure, because we need to check each number once, and then we need to do a recursive loop in order to check for if it is a valid or not. So that will be an we have two choices, either to pick it up or not, kind of an 0 1 knapsack. So exponential, uh, so then it is the time complexity will be O of n into 2 to the power, and how many times we have this choice. So basically we have two choices, either to partition or either to not partition, and how many times we're going to partition it. We're going to partition it until the maximum the number of digits we have. So this will be 1000 square is 10,000, and that will be log of n. Here n is basically the number of digits, so we can take it like m, or it should be n, log of n on the base of 10, log 10 base n. Yeah, so this should be the time complexity, and this will work for our constraints. So I'm thinking of writing a code for it. Let me write it. Let's write. So first thing first, we need to return an int. So we'll create an int. We call it punishment. We call it result. Not 0, because it needs to be a sum of the punishment, the numbers which are valid or not. So, and as I have said, that we need to loop through. Let's say iteration equals 1, I less than equal to n, and until now we need to check if it's a valid number or not. So if is valid, and this is the I, and if it can be partitioned to himself. Let's just do this one thing. I don't want to be, my code should be readable enough. So let's write meaningful variable names. So I want to check if the num is valid. Okay, so it can, or maybe can partition num with this num, basically the sum. If it can be partitioned, the num is partitioned to the num. If it is, then it's a valid number. So result plus equals the number square. Otherwise we won't do anything, and return the result in the end. Let's write this function for can partition. Okay, so we need to partition this number. We can like partition this number. This should be a square. Okay, so this should be a square, and if it is equal to themselves, then it's good. And I need a string here because I want to do string manipulations. So first of all, it's a boolean, can partition string empt num. Here it's an integer, so need to change it to the string. So we have the string num and int value. So now we need to check. So now we need to go through. We need to do a recursive loop. What I can do is I have this, so I need to go through all the length. So length will be number dot size, and I will loop through all the indexes. Index lesser than n plus I, and after this, let's say for this number I am on 0 index, I need to construct a number. I'm on this index, I need to partition it. So I need to pass this string, and I need to do a subtraction from the square, which is a number from, and it this number. Okay, so we need to do is we need to make an int current or we can call it, this number needs to be separated, right? So what should I name this variable? This is one of the trickiest part. Okay, let's say current number should be 0, and current number will be the num string minus 0. Okay, we need to construct a number. Construct a number will be, we need to make it this as well, so that we can, like, construct a number like this. Suppose we have digits 1 2 3 4 5. Now I need to partition this 3-digit number. So in order to convert this 123 to a integer, I need to do this. So 123 can be written as 0 into 10 plus 1. Then this whole number, how can I understand? It's a basic algorithm basically, to construct a number from digits. So first we get a 1 digit, then we multiply it with 10 to make it 10, then plus 2, so it will become 12, and then we multiply again with 10 plus the digit 3 to make it 123. So it's just I'm what I'm doing is I'm taking all the digits, and I'm making a number out of it. So basically a string to number conversion. I will write it here as well as a comment. String to number conversion. Okay, so we have this number which we need to separate. Now we just need to do if can partition, which is the recursive call, the rest of the number, which will be substring num dot substring and index plus 1, because we are going to with the next one, index plus 1. And if it can partition and the value minus the current num, if it can be partitioned to this, then it is valid, so we return a true. Otherwise won't return a true, we will return a false in the end. So if it can be happening, if it we can partition it, so we will return a true. Now if we left this, we need to think of a base case to stop this recursion. So we made one more observation. If the string length is 1, we can simply check it to themselves. So if n equal 1, just return the num is equal to num 0 minus 0. Basically we need to character conversion. If it is, then it's, otherwise if the length is 0, which can happen in the last place, then also we need to return a true. N equal 0, return true. What else can be happen? So if n is greater than 0 and 1, or if the value is becoming lesser than 0, then return a false. Because if the value is negative, now you cannot build a, it cannot be equal to themselves because it's all positive. So that will work, and I think it should work. So let's give it a run to see if we encounter any errors. Okay, we do got return num. Okay, num is a string, and that is a if n, okay, it should be equal to value. Num0 minus 0, it should be equal to the value. I'm sorry for that. Then cannot bind a temporary type non-const reference to basic string. Okay, so I found the bug. So the bug is still in the we had this pass by reference. So when you try to pass the string here, so it will create a new string and it will override the string. So this value will cannot, it's illegal to substitute one value to another in memory. So you need to remove this. So another bug which I found is, so suppose we have an empty string here, so and we have a value which we need to transition the string to. So if the string is empty and we have a value, it is impossible to transition it. Suppose, for example, we have empty string, but we need to check if we can partition this empty string to a number, something like 7679. We cannot do this because it is always 0. We cannot partition an empty string, so this value also needs to be 0. So we can like do this, return value equal 0. So after this, I think it should work. Let's try to submit it. Yes, and we submitted it and it's worked. We beaten 69.52%. Great.